Good morning, all.
Good morning, sir.
Good morning, sir.
Mute
Good
Good
morning,
yourself.
sir.
afternoon.
Mute yourself.
Good morning, sir.
Good morning. Mute yourself. Write your name and seat number in the chat box. Riya Charekar, Nita Chaudhary, mute yourself fast. Nita, mute yourself. Otherwise, I have to mute all. So yesterday we are discuss about the types of reagents. Anyone tell me screen is visible to all?
Yes,
Yes, sir.
Yes, sir.
Okay, okay,
Yes, sir.
okay.
Yes, sir.
मला इथे गठू
Onkar, Sanika. Onkar Nide, mute yourself. So we will start. Yesterday we discussed about these types of reagents, electrophiles and nucleophiles. Electrophiles are positively charges, means these are electron loving species. They accept electron from the substrate. Remember, actually these are electron deficient species, electrophiles. Yesterday also I discussed about the electrophiles, Br plus, how this Br plus is generated, CS3 plus, means these are positively charged. And opposite to this electrophiles, the another reagent is nucleophiles, nucleus-seeking species. They donate electron to the substrate. Nucleophiles are electron-rich species. They having lots of electrons. That's why these are called the electron-rich species. For example, a negatively charged species such as OH minus or a neutral species such as H2O. This oxygen having lone pair of electrons. NH3 in ammonia, nitrogen is also having the lone pairs of electrons. So yesterday we completed this part. One problem is given here. Identify the nucleophile and electrophile from NH3 and CH3 plus. Also indicate the nucleophilic and electrophilic centers in them. Justify. So its answer is also given. The structural formula of the two reagents is given here. This ammonia having the lone pair electrons here, nitrogen having the lone pair of electrons. See, the electrons are shown, but little but faint electrons are there. And this is CH3 plus, carbon having positive charge. So as per the definition of electrophiles and nucleophiles, in case of this NH3, nitrogen is the center element which is having lone pair of electrons, which can be given to the another species. So as the electron pair is given, these NH3, it is acts as a nucleophile, and this CH3 plus the carbon, its plus show videos not required for the lectures. Remember, videos are not required for the lectures, only audio is sufficient. So this NH3 acts as a nucleophile and CH3 plus, because of this positive charge, it is a electron deficient species, so it becomes electrophile. Remember, So such type of question may be asked for your examination for 2 marks. Identify the nucleophile and electrophile. It is very easy to identify electron deficient species and electron rich species. Also, it is a sub question is given. Also indicate the nucleophilic and electrophilic center in them. Justify. So the answer is given. The CH3 plus is a positively charged electron deficient species having the vacant orbital on the carbon. This carbon orbital is vacant because there is no electrons. So it is an electrophile. The carbon, it is the electrophilic center. The carbon is the electrophilic center and the nitrogen is the nucleophilic center. A polyatomic electrophile has an electron deficient atom. It is called as electrophilic center. So what is mean by electrophilic center? Please try to understand. A polyatomic electrophile has an electron deficient atom. इलेक्ट्रॉन डेफिशियंट ॲटम म्हणजे ज्याच्याकडे कमी इलेक्ट्रॉन आहेत किंवा इलेक्ट्रॉन नाही आहेत त्याला म्हणतो आपण इलेक्ट्रॉन डेफिशियंट ॲटम. इट इज कॉल्ड एज इलेक्ट्रोफिलिक सेंटर. while a polyatomic nucleophile has electron rich atom, it is called as nucleophilic center. So in this example, this carbon is the electrophilic center and the nitrogen is a nucleophilic center according to the definitions. See, here also examples are given. The electrophilic center of the electrophile AlCl3 is aluminium. In case of aluminium trichloride, this aluminium is a electrophilic center because aluminium which has only 6 valence electron, so this is a electrophilic center. Electron deficient, aluminium is electron deficient, remember. Then the nucleophilic center of the nucleophile H2O. In case of the H2O, all of you know the oxygen having the lone pair of electrons. So oxygen which has 2 lone pair of electrons, it is a nucleophilic center. In ammonia also, nitrogen is a nucleophilic center. And in case of AlCl3, aluminium is the electrophilic center. Remember, these are the two different species, electrophilic center and nucleophilic center. The nucleophile attacks. Now I am coming to the nucleophile. Nucleophiles are the species which are electron-rich species. A nucleophile attacks the electrophilic center in the substrate. म्हणजे ज्याच्याकडे सगळ्यात जास्त इलेक्ट्रॉन्स आहेत तो कुठे अटॅक करतो, ज्याच्याकडे कमी इलेक्ट्रॉन आहेत. न्यूक्लिओफाइल ऑलवेज अटॅक्स ऑन द इलेक्ट्रोफिलिक सेंटर, म्हणजे ज्याच्याकडे इलेक्ट्रॉन कमी आहेत, and brings about the nucleophilic reaction. That reaction is called as nucleophilic reaction. Remember, in case of nucleophilic reaction, nucleophile which is electron rich attacks on the electrophilic center. Electrophilic center means electron deficient species. On the other hand, electrophile attacks, now opposite to this nucleophile. I am coming to the electrophile. Electrophile, you know, it is electron deficient species. Electrophile attacks a nucleophilic center in the substrate and bring about electrophilic reaction. So there are the two different reaction. In case of nucleophilic reaction, nucleophile attacks, and in case of electrophilic reaction, electrophile attacks. So the principle is explained in this example below. We can see. See, this NH3 acts as a nucleophile. This nitrogen, which is having the lone pair of electrons, it is donated to this BF3. This, in case of BF3, this boron is electron deficient. This acts as electrophile. BF3 acts as electrophile and this NH3 acts as a nucleophile. Hence, the nucleophilic center nitrogen. See, this nitrogen is a nucleophilic center because it is electron rich. It attacks on this boron because this boron is electron deficient and gives this product. This is the product is given here. Now, how the electron movement takes place in the reaction, it is shown with the different arrows here. This is very important. Actually, this is not given in your textbook. But if you want to understand the mechanism of the reaction, this is very important. How the electron movement takes place in the reactions. Only in your textbook one paragraph is given, but these diagrams are not shown. These examples are not given. So purposefully I taken these examples from the different book. See, the movement of electrons in case of organic reactions can be shown by the curved arrow notation. We can see here, this is the curved arrow. This curved arrow indicates the electrons from this double bond. These are shifted here. So it becomes, these electrons are transferred here and single bond is converted into double bond. So here it is written from pi bond to adjacent bond position. One is sigma bond and one is pi bond. So the electrons are shifted uh, from this double bond to this single bond. So this double bond is converted into single bond and single bond is converted into double bond. Electrons are shifted from here to here. Then again in second example, from this pi bond to adjacent atom. This is first case. We can shift the electrons to alternate adjacent bond position also. We can shift the electrons, this pi bond to adjacent atom. So if these electrons shifted to Y, this Y will acquire the lone pair of electrons. So it is clear cut, it is shown. So the electron, it is shifted, we can see here the lone pair of electron. And again the third example is given from atom to adjacent bond position. This atom, Y having the lone pair of electrons, we can shift this electron pair to adjacent bond. So we will get here double bond. We will get here double bond. This electron can be shifted. So these are the some examples which are shown how the movement of electron takes place. So go through it. This is actually no any question will be asked on this point, but these movements of electrons you should know during the reaction and mechanism. You should know how the electrons are shifted or how the electrons are moved. Here, movement of single electron is indicated by the single barred barbed. It is also called as fish hook arrows. Fish hook, in bracket, it is denoted half-headed arrow. Yesterday, uh, in the classroom, I explained how in case of HNU, UV radiations, in case of UV radiations, that is homolysis fission. In case of homolysis fission, I have shown this arrow. We can see in this example, see CH3Cl, if UV rays if the reaction is taken place in the UV rays, we can see these arrows. These two arrows are called as fish hook arrows. Fish hook arrows. See, means this is the symmetrical breaking of bond. We get here free radicals. CH3 dot. This is CH3 radical, and this is Cl radical. Cl dot. These dot indicates two electrons. Um, but in this example, we can see in transfer of hydroxide ion giving ethanol in the dissociation of chloromethane, the movement of electron using the code arrow, it is shown here. See in this example, this is OH minus, this is a nucleophile. This OH minus is a nucleophile because oxygen having the lone pair of electrons. So it is electron rich. So this lone pair, if it is this lone pair attacks on the CH3 here because it is a electrophilic center. Carbon is electrophilic center. If it attacks here, so this bond will be broken. The bond between CH3 and bromine will be broken. And see, this electron density will be shifted to this bromine. It becomes Br minus. It becomes Br minus. So this is one example how the movement of electron takes place. The next point is electronic effects in organic reactions. So first I will explain what is meant by these electronic effects. The displacement of valence electron resulting in polarization of an organic molecule, it is called as electronic effect. See, once again, I will explain. Electronic effect means what? The displacement of valence electron means here displacement of valence electron which are present in the valence shell. It is called as valence electron. So, the displacement of valence electron results in polarization. Polarization means plus and minus charge will be separated. This is called as polarization. Polarization of an organic molecule. It is called as electronic effect. So this electronic effect, it is occur in the ground state. It is a permanent effect. This is due to the influence of a certain atom or substituent or certain structural feature present in the molecule. After example, it will be uh, more easy to understand. I will give one example. So, electronic effects in which the displacement of valence electron takes place. See, inductive effect and the resonance effect are the two examples of this electronic effect. Inductive effect is one of the electronic effect, and resonance effect. In both the effects, displacement of electron takes place, and it results in the polarization. On the other hand, electron displacement effect occurring in a substrate due to the approach of attacking reagent. It is temporary effect. So electronic effect may be permanent or electronic effect may be temporary. So these inductive effect and resonance effect, these are the permanent effect, remember. But there is another effect which is temporary effect. It is called as electromeric effect. Electromeric effect, or it is also called as polarizability effect. This is temporary effect. This is occur due to the approach of the attacking reagent. This type of effect is called as electromeric effect or polarizable effect. Now we will discuss with the help of examples. First, I will explain this inductive effect. Very important for the examination point of view. This inductive effect is very, very important. Note down. It is asked for the examination. Write a note on inductive effect for 2 marks or 3 marks. Bigger question can be asked on it. So if it is asked, definition is very important. First, we have to write the definition. When an organic molecule has a polar covalent bond, remember this is the first condition for inductive effect. When an organic molecule has a polar covalent bond, the bond should be polar. Polar means it should be separated with positive and negatively charges. It is called as polar. So this is the first condition for the inductive effect. Then and then inductive effect is possible. If the molecule is not polar, non-polar, there is no possibility of inductive effect. So polarization should be there, a polar covalent bond in its structure. Then what happens? Polarity is induced in adjacent carbon-carbon single bond. See, when organic molecule has a polar covalent bond in its structure, so polarity is induced. That's why it is called as inductive effect. Inductive means new polarity is induced. That's why it is called as inductive effect. Remember, polarity is induced where in adjacent carbon-carbon single bonds. Two, म्हणजे मराठीत आता सगळ्यांना समजतं म्हणून थोडंसं मराठीत सांगतो. ज्यावेळेस पोलर कोव्हॅलंट बॉन्ड असतो, लक्षात घ्या. पोलर कोव्हॅलंट बॉन्ड म्हणजे इथं खाली एक्झाम्पल दाखवलेले बघा, इथं CH3 CH2 Cl. दिस Cl इज इलेक्ट्रोनिगेटिव्ह. सो दिस Cl minus and it will be plus. This minus plus. So it is a polar covalent bond. So due to this polar covalent bond, what is given in the definition? Polarity is induced in the adjacent carbon-carbon bond. So due to this Cl, this becomes also polar. This bond, we can see this bond. This bond is already polar. This is a Cl minus. This is CH2 plus. But due to this Cl minus, polarity is also induced here. This carbon. So this is called as inductive effect. So this example is given, the chloromethane. In the chloromethane, this chlorine is electronegative species. So polarity is developed in this molecule. The positive polarity is developed on C2. This C2, this is carbon number 2. It is called as C2. Explanation is given. In this molecule, a positive polarity is developed on C2 by the inductive effect of the chlorine atom, which is bonded to C1. म्हणजे या एक्झाम्पल मध्ये बघा, Cl हा कोणाला जोडलेला आहे, this carbon number 1. So actually this bond is polar, but due to this chlorine, the positive polarity is induced on the carbon number 2. It is called as inductive effect. It is called as inductive effect. Normally this C2, normally C2 and C1 bond would not be expected to be polar. म्हणजे C2 आणि C1 हा बॉन्ड पोलर असण्याची काहीच गरज नाहीये, लक्षात घ्या. कारण तो जो बॉन्ड आहे तो दोन कार्बन कार्बन मधला बॉन्ड आहे. दिस बॉन्ड इज प्रेझेंट बिटवीन द टू कार्बन्स and see the electronegativity of this carbon and electronegativity of this carbon is actually same. This carbon is electronegativity is same. तर हा C2 आणि C1 बॉन्ड पोलर असण्याची काहीच गरज नाहीये. बट ह्या क्लोरीनमुळे याच्याकडे ते पॉझिटिव्ह चार्ज येतो. याला इंडक्टिव्ह इफेक्ट म्हणतात. लक्षात घ्या. कळते का बघा? मला जरा थोडंसं माईक ऑन करून सांगा.
हो.
समजते का? म्हणजे ह्या क्लोरीनमुळे काय होते, हा क्लोरीनमुळे याच्यावरती पॉझिटिव्ह चार्ज येतो या C2 वरती. The induction means positive charge is developed on this C2 because of this chlorine. It is called as inductive effect. So the explanation is given here, detailed explanation is given how this Cl pulls the electrons from this C1. कोणाचं तरी माईक चुकून सुरू आहे. सुदर्शन, mute yourself. Mute yourself. Okay. So how the polarity is induced, I will explain here. So I explained this one. Normally this C1 and C2 bond is not polar, but due to this Cl, this bond become also polar. Yet this bond acquires some polarity because of the presence of chlorine. आपलं वेळ संपल्यानंतर परत त्याच लिंकवर क्लिक करून जॉईन व्हायचं बरं का, लक्षात घ्या. आपलं 1 तासाचं लेक्चर आहे 11:15 पर्यंत. जरी वेळ संपली, आता 10 मिनिटं राहिलेले दाखवते मला नोटीस. त्याच्यानंतर परत तुम्ही ही मीटिंग संपली की त्या लिंकवर क्लिक करून परत जॉईन व्हायचं. ठीक आहे. At this bond acquires some polarity because of the presence of chlorine atom. हे सगळं कशामुळे होते? Why this is happening? Because of this chlorine. Chlorine being the more electronegative than the carbon, the C1Cl bond is already polar. C1Cl bond is already polar. I explained the positive charge here. It is developed due to this chlorine. See, this line is very important. And equal amount of partial positive charge on C1 here means this bond is polar because chlorine is electronegative. It will pull the electron. So जेवढा चार्ज याच्याकडे निगेटिव्ह डेव्हलप होतो तेवढाच पॉझिटिव्ह चार्ज याच्याकडे C1 वर डेव्हलप होतो. लक्षात. As C1 is further bonded to C2. This C1 is bonded to C2. So the positive polarity of C1. इकडे बघा. Why the C2 carbon acquires the positive charge? I am explaining. The positive polarity of this C1 pulls the shared pair of electrons of the C2-C1 bond. म्हणजे C1 वर जी पॉलॅरिटी डेव्हलप झालेली, जी पॉझिटिव्ह पॉलॅरिटी डेव्हलप झालेली कोणामुळे? या क्लोरीनमुळे. What happens there actually? This C1 pulls the electron density from this C2 to C1. So it becomes positive. C2 also becomes positive. C2 also becomes positive. So as a result, what happened? A part of partial positive charge is also produced on C1 is transferred to C2 लक्ष द्या. So because of this Cl, C1 get partial positive charge, also C2 gets partial positive charge. This is called as inductive effect. Detailed explanation only given in this example, but if it is asked for the examination, write this molecule, or you can write here bromine also, we can write here fluorine also, we can write here iodine also. We can give the any example. Instead of this chlorine, we can write bromine, we can write iodine, we can write fluorine also. But fluorine is highly reactive, but in some cases fluorine compounds are very reactive or not stable. So we can give the example of chlorine. Because of this chlorine, partial positive charge is developed on the second carbon. It is called as inductive effect. So for the explanation, for the understanding purpose, the detailed explanation is given how the positive charge is developed on this C2. How the positive charge is developed on C2. This detailed explanation is given. So I think you can read at your home. So inductive
Sir,
effect. हाँ बोला.
डेफिनेशन आणि फक्त
एक्झाम्पल
लिहायचं ना,
द्यायचं
मग
हो.
एक्झामला विचारलंय.
म्हणजे हे एवढं
एक्सप्लेनेशन नाही
लिहायचं,
ना?
एक्सप्लेनेशन लिहायची गरज नाहीये, एवढं लिहायची काही गरज नाहीये, हे फक्त समजण्यासाठी दिले तुम्हाला. At the time of exam only we can write
Okay.
this definition and this example only. Because of this chlorine,
Yes, yes, okay.
positive polarity is induced on the second carbon. That's it. मग ते कशामुळे होतं, का होतं, ते लिहायची काही गरज नाहीये. ठीक आहे, हे तुम्हाला समजण्यासाठी डिटेल एक्सप्लेनेशन इथे दिलेले. At the examination it is not required, but I want to explain one more thing. As the number of carbons here increasing, the inductive effect will be decreasing. See, this inductive effect will be very strong. Chlorine and the first carbon, this inductive effect will be decreases in the second carbon, then third carbon, fourth carbon. Avishkar Madi, mute yourself. Follow the protocol of the online lectures. Mic चुकून आपलं सुरू राहतो, बंद ठेवा. So what I am explaining, this is asked for the JEE, NEET and CET exam. As the number of carbons increases, the inductive effect will be decreases, remember. So here we can see delta 1 plus, delta 2 plus, so delta 3 plus, delta 4 plus, delta 5 plus. As the number of carbons here increases, the inductive effect will be decreases. But this inductive effect will be very strong. Carbon number 1 and this chlorine. So this inductive effect will be very strong. As the carbon increases, the inductive effect will be very, very small, and it will be negligible in the if the 4/5 carbon 5 carbons are there, it is very, very negligible. So there are two types of inductive effects. First one is minus I effect. Minus I effect is electron withdrawing effect, and second one is plus I effect. Plus I is electron donating effect. So for example, first example already chlorine is given. Chlorine withdraws the electron density from the carbon chain. So it is minus I effect. Minus I means which group is attached, that is responsible. ते कशावर रिस्पॉन्सिबल असतं इथं बघा. क्लोरीन हा ग्रुप कुठला आहे, इलेक्ट्रॉन विड्रॉइंग आहे. हा इलेक्ट्रॉन डेन्सिटी आपल्याकडे ओढून घेतो, म्हणून त्याला काय म्हणतो आपण, इलेक्ट्रॉन विड्रॉइंग इफेक्ट, मायनस आय इफेक्ट. Chlorine is said to here electron withdrawing effect or negative inductive effect, that is also called as minus I effect. There are some examples are given, some groups which shows minus I effect. NO2, this nitro group also withdraws the electrons. Cyano group, cyanide also withdraws the electron. Then COH groups, carboxy also withdraws the electron. Ester also withdraws the electron. Then ariloxy, OAR, that is methoxy, ethoxy group. All these groups are minus I effect. Means if these groups are attached here to this carbon, these are called as minus I effect. And opposite to this minus I effect, there are plus I effect. Plus I effect, these are electron donating effect. So the groups are alkyl groups. This alkyl groups are considered as a electron releasing effect, plus I effect. हे काय करतात, इलेक्ट्रॉन डोनेट करतात, लक्ष द्या. इलेक्ट्रॉन डोनेटिंग इफेक्ट, आणि हे सगळे जे ग्रुप्स आहेत ते इलेक्ट्रॉन विड्रॉइंग इफेक्ट. तर हे परीक्षेला विचारतील, राईट वन एक्झाम्पल ऑफ इलेक्ट्रॉन विड्रॉइंग और राईट अ नोट ऑन मायनस आय इफेक्ट आणि प्लस आय इफेक्ट. इथे फक्त अल्किल ग्रुप्स लक्षात ठेवा, दीज आर इलेक्ट्रॉन डोनेटिंग. Then one problem is given. So these problems are for your practice. We can go through this problem. Answer is also given. Just we will discuss this one problem. Consider the following molecules and answer the questions. Number one is given here: CH3, CH2, CH2, Cl. Anyone can tell me the name of this compound fast, immediate? याचं नाव सांगायचं पटदिशी. कोण सांगते? लवकर.
क्लोरोप्रोपेन सर.
क्लोरोप्रोपेन.
ओके, माईक बंद ठेवा आता. क्लोरोप्रोपेन किंवा अनदर नेम इज प्रोपिल क्लोराइड असं म्हणू शकतो का मी? क्लोरोप्रोपेन और प्रोपिल क्लोराइड. येस. सो इथे आपल्याकडे CH3 CH2 दिले, इथे पण ब्रोमीन दिले आणि इथे आयोडीन दिले. ठीक आहे. आणि व्हॉट इज द क्वेश्चन इज आस्क्ड, व्हॉट टाइप ऑफ इंडक्टिव्ह इफेक्ट इज एक्सपेक्टेड. आताच सांगितलं मी तुम्हाला की ऑल दीज आर मायनस आय इफेक्ट्स. Chlorine also withdraws the electron, bromine also withdraws the electron, iodine also withdraws the electrons. So all these shows the minus I effect. Then what is the second question? Identify the molecules from these three having the strongest and the weakest inductive effect. Yes, anyone can guess which of this chlorine, bromine and iodine, which is स्ट्रॉंगेस्ट इंडक्टिव्ह इफेक्ट. ते कशावर डिपेंड असतं ते सांगतो मी तुम्हाला. या क्लोरीन, ब्रोमीन आणि आयोडीन म्हणजे जो सर्वात जास्त इलेक्ट्रोनिगेटिव्ह आहे, जो सगळ्यात जास्त इलेक्ट्रोनिगेटिव्ह आहे, तो सगळ्यात जास्त विड्रॉइंग इफेक्ट दाखवेल. लक्षात घ्या. मीन्स this chloropropane, bromopropane and this is iodopropane. या तीन मधला सगळ्यात जास्त इलेक्ट्रोनिगेटिव्ह कोण आहे? क्लोरीन, ब्रोमीन, आयोडीन मधलं इलेक्ट्रोनिगेटिव्ह कोण आहे माहिती? एनीवन?
क्लोरीन.
रिझन सांगायचं.
आयोडीन.
कोण आयोडीन सांगते, कोण क्लोरीन सांगते, कोण ब्रोमीन सांगते? Actually, I will explain. Fluorine, chlorine, bromine and